All right. This one is for CAPE students. So if you're on the inside, message me. Alright, send a message in chat now. Let me know you're there. Danara. Right, good night, Danara. The ComSci is 500 month, including IA. $400 with no IA. Alright, so like one time, we'll start off with 4. Comments. Alright, there you go. Alright, so here's my issue with structures, right? I need to get feedback to make sure that people understand that. So one or two things. Somebody had to send me the Skype username so I could call them. So I could get I could get to ask questions, because if I'm teaching something and you do understand, anything will make sense, I'll move on to the next partner. So I would really love it if I could just call one person on Skype. You go stay muted for the whole time. It's audio only, and whenever you have a question, you could give me feedback, because it will help not just you, but it'll help the people that are watching also, because they might have questions. So because the chat does lag too much, and some of the questions you have to ask will be too long to type, because I need to understand what's the exact problem. So anybody, somebody, help the people out there. Alright, well, I'll just jump in. I'll just try to jump in and explain it as best as I could. If you do understand, send a message in the chat, right? Maybe one day I'll be able to get the a live student just for teaching purposes. Alright. So how a structure is made up is that it's something called a data type. As far as we know, data types are usually int, float, or char, right? Now, int means that it could only hold numbers, positive or negative whole numbers, so like positive 5, negative 5, but no decimals. A float could hold positive or negative, but it could have decimals, blah blah blah, so it acts up in decimals. Characters will be any character on the keyboard that was like a question mark, $, W, $, anything like that will be a character. So that used to work good because right, so everybody understand now so far that a data type could be all of these here, right? Now if each of those is a data type, what happens is that a structure is like when you have a cupboard with multiple compartments. So you could create one data type called, let's call this S, right? And you could put integer, which could be 5. You could put float, which could be 4.9, and you could put a character, which could be $. The data type called S is now consisting of everything that is inside this cupboard here. So kind of the reason they create structures is to like save you from doing parallel arrays. Because if you had a parallel array or a parallel set of structures, you would have a whole set of information that kind of stacking up onto each other. So let me say you need to get somebody's age. So int age, and then you have int, I don't know, pay, and then int, I don't know, gender. You'll have to read each one of them, and you'll have age equal 25, pay equal 3000, and gender equal male. And you have to keep reading that over and over and over and over. What structure does it? It creates one big container to hold all of that for this one person, and it just gives it one name, which will be like person. So everything that pertains to that person will be in here. So instead of having 3 separate variables, variable 1, variable 2, and variable 3, you have one variable name called person that has 3 sub variables inside of it that you could use to store the information, right? So a structure is like a cupboard with shelves. So before I move on, let me know if you understand that. If you do understand that, then you might have a little problem. Let me know. At least a thumbs up, kids. At least. Alright, cool. Thank you very much. Denara. Alright. So let's go now. When you're declaring a structure, you need to give it a name. So you have to use the word struct and you have to use a name for it. So when I say struct database, this is the actual data type here. So this is me saying, just like how I could say int age, that means I'm going to hold a number inside a box. If I say struct database, that's the same thing as int age. Same concept. So once I say struct database, I in my code, I'm saying I want to have inside the structure an integer called ID number, an integer called age, an integer called salary, a character, a name called name. That's how I declare a name. And the name of the structure, I want it to be called employee. So this semicolon here kind of ends off the name of the structure. So therefore, I get this. The name of the structure is called employee. I have a space to hold an ID number, I have a space to hold an age, I have a space to hold a salary, and I have a space to hold a name. Good? So what's going to happen is I'm going to now be able to fill. Sorry, everybody okay with that there? Let me know if you're okay with that. If you have a question. No questions, right? Alright, so we're looking good there so far. Alright. So now if I want to put information into this, I could say employee age equal 22. Employee.age. Now this dot here is going to now say in the employee structure, I want the age to be 22. So when I say employee.age equals 22, that means put the 22 inside that part of the thing. When I say employee.id number is 1, I'm saying employee.id number goes here. Then I say employee.salary goes here. And then I say employee.name goes there, right? You can't actually do this, but this is for, like, you had to use string copy for that to work, but that's just for experimenting, for illustration purposes, right? They could fill anything up. So that's how we fill information into our structure. All right, so now that you've seen that, let's go to some code. So look at this example here. Structures example 1, let's see. All right, so we're going to go through this code line by line so you understand. And if I could put this in the chat, boy. Don't you could put a text file in a chat. Let me see. Copy. Oh, I could copy the Dropbox link. Peace. Alright, if you're on a computer, download that file to your computer now. When you're finished downloading, let me know. If you're not downloading, let me know too before I move on. Alright, to download. Let me know if it downloaded. Open. Alright, cool. So we're going ahead. Right, so line by line. So I create this thing called struct database, and then I have a ID number, and then I have an age, I have a salary, and I have a name, which is what I just did. So this here tells the computer, create a space that will hold these 4 things for me, and the name of that data type is going to be called database. Right? So when I go to my main now, you should know what main is, right? And I say struct database, and the name of it is employee. I'm actually creating an employee that has these 4 spaces empty, waiting to fill up with stuff, right? So when I put the code in now, go and click employee age equal 22, employee ID number equal 1, employee salary equal 500.00, because that was what has a float, right? Salary is a float because we are decimal. And then I'll printf, please enter name, and I'll go and say scanf the employee name. So what it's going to do is it's going to create a structure called employee, and then to print it back out now, I print the ID number is employee.id number. So this employee.id number will latch back onto this map back onto that %d, because that's an integer. This %d will latch onto employee.age. This %f, well, I'll put 0.2f so I can get 2 decimal places, will latch on to the employee salary, and this %s here gonna latch on to the employee name when I print it back out. So if I run this code, what's going to happen is I'll get this coming up, enter name, which is line 20, right? So the reason I've seen enter name is because this part here is printf enter name, but all this stuff already happened in the back. When the 22 went in, the 1 went in, the 500 went in, so I'm just going to enter name. I'm going to enter the name as Bob. Boom. The ID number is 1, which was set to 1. The age is 22, which was set to 22. Salary is 500, and the name entered is what I entered, Bob. So it printed back out based on what I set to print out here. Is that. So that's what would happen. Alright, so you could try that. And if you have questions, ask it now before I move on to the next something. If not, let's tell me to continue, because so we could move on to array of structures. Safe. Alright, cool. So now we're going on to array of structures. Right, so array of structures is like a row of cupboards with multiple shelves, right? Now, when I say multiple shelves, it's kind of like creating a database. So let's say I have a structure called database, and I have an ID number, age, salary, and name, and I put E5, right? What that means is when I say E5, that means I want to create 5 of these structures, and I want to name them E. So when I create the array, it's going to have E location 0, E location 1, E location 2, E location 3, and E location 4. Because we should know that arrays start from 0. If our array starts from 0, each one of them will have a location. So I could address it by saying E location 0 dot ID number could be, I don't know, 5, or age could be 20, or salary could be 500, and name could be Bob. So this will be location 0, and then using an array I could make it do each one of these, like this one could be ID number 6, age 21, salary 300, and this could be Pam. And you could see how when you use a for loop, you'll be able to pelt through that. So if I were to address each one, I could say E022, ID, John, blah, blah, and that will fill up all the information in there. And then I could do the same thing for E location 1 now, because the 1 is going to have the ability to jump to this side now. So if I have each one of them, let's call this word, named differently, then I could go from one structure to the next structure, just like that. Good. Before I jump into our example, ask any questions. See if I can find the example. What I do now, boy? Fine, looking for an example. So let's say we have structures example 2. Okay. Follow along with this code, right? Alright, hit my thumbs up if you're okay there. Good. Yeah. Right. Alright. So let's look at the code. The name of the struct is student. Why did I name it student? Is because it's a student. The student has a name, they have a number on the roll, and they have marks that they will get for whatever subject it is they're doing. So I'm going to now create the main. So I've struct student S10. Remember, once I put S10 here, what I'm actually doing is creating an array of structures. And the array of structures is like, what happening here is once I say S10, I'm creating something with 3 spaces, but what I'm actually doing is having 0, S0, S1, student 1, student 2, well, student 0, student 1, student 2, student 3, and so forth. But all of them going to have the 3 concept, which will be name, role, and marks. And each one will be filled automatically once I start to use my loops, right? So let's see how we use any loop. I have to create an integer I because I use an integer I. Most people just create an integer C for a counter for the loop, but any variable could be used for the looping. I have I is equal to 0, I less than 10 plus plus I, so you could use plus plus I or I plus plus, or both of them do the same thing. Even if you're like, sometimes you might see a past paper question where you see plus plus I, and then sometimes you might see I plus plus. But just remember, they're incrementing. You don't need to know the factors, postfix and prefix right now, right? So, the first rule is now to say si dot roll is equal to I plus 1. So what I'm doing is I'm saying s location 0 dot roll is equal to I is equal to I plus 1. So what happening there is alright, so as soon as I say that, what happening is I have these 10 spaces that have been created. And the 10 spaces that have been created are going to be, thanks, I appreciate it. No, better, good. Right. 10 spaces that have been created will be S0, S1, S2, and S3, going all the way up to S9, right? Right, so the first time that runs, it's going to be S location I, which started off at I is equal to 0 because I'm a for loop here, is equal to roll is equal to I plus 1. So what is the value of I? 0 plus 1. So their roll value will be 1. Just now, I'm going to get the colors change up here. Yeah. Right. So the roll value will be 1 going inside here. Because of that, I is equal to I plus 1 then. Then I'm going to print up for roll number, enter name. So I'm going to enter the name. The name will be Bob. I will fill up there, and then I'm going to enter marks. The marks could be 50. So that will be for S0. Now, when I go and loop again, the I is going to change from 0 to 1. So now I'll be looking at S location 1. So when I go and loop again, now it will be S location 1. Now we're looking at here, because we finish with here, we jump across to this one now. Because the for loop is going to change from 0 to 1. When the for loop changes to 1, that one now is going to now fill up the information. So it's going to be roll plus 1. So 1 plus 1 will be, that is I plus 1. So that will be roll number 2. So automatically the increment in the numbers as we go up. Then I'll go ahead and enter the name, which will be Pam. And I'll enter the marks as 40. And then, well, you can figure out what will happen now. It will jump to 2, then it'll jump to 3, then it'll go all the way up to 9 eventually. And we'll have all this stuff. We'll have all this stuff filled out. All here we fill out, blah, 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 blah. Filled up. Ting, ting, ting. And then the last part now will be displaying the information for the students. So if I want to display the information, I'm going to create a new for loop. And I'm just going to print out the number, which is I plus 1. And I'm going to print out SI name and then SI marks. And that's also works. So let me compile this and see what happened. So enter for rule number 1. Why does that come up? Because I have for rule number 1, right? So I'm going to put in full name Bob got 45. Rule number 2 Pam got 46. Rule number 4 Bill 67. I'm just going to use letters of the alphabet now. Okay, Andre 78. Timmy, Dion, Phil 89, Danny, 68, and Tom 89, Janice, and now I'll print back out all of them for now based on the second for loop. And all of these printing out from the structures. Alright, then you kind of understand a little bit about how it differ from files. Alright, so if you understand how structure is working now, let me see if I could just flip through to files quickly for you. Files. Where's files? Files. Okay. Alright, so if you understand those structures examples there, then you know how to look through a structure, right? A file is basically you taking the information from a text file or data file or whatever, and you're reading it in different modes, right? So when you're declaring a file, the easiest way to show you this is with an example. So let me get the file examples of files. Reading from a file. Let's see, right? Unopening. Oh, you did. Sorry. Yes, you did. Where are you? Reading from a file. Okay. So here our filers work. When I say file in, that says I want to name the file in, right? The name of the file for the rest of this program will be referred to as in. And when I say fopen, input.txt, that's the name of the file. Now, the most important thing is that when you create this file, it must be in the same place that the program is. So right now my program, read from a file C, is here. I have the input file right next to it. It is in the exact same folder. If it's not in the exact same folder, the file wouldn't read. So it's very important that the input file be in the same place, saved in the same place that the folder is, right? Remember that. So I have input.txt, and the mode I put in it is in read mode, right? So there are multiple modes. First one is read. That's when you want to read data from the file only. Next one is write. That's when you want to write data from the file. And then read and write is when you want to read or write from it at the same time. So you could read from it and write stuff to it, so you'll add more. But and then append will be if you want to have a file that has stuff already, you could add more stuff to it. So usually when you open a file in read mode, it will read all the information. And when you close our file, the information will still be there. When you write to a file, the information will be there. But when you close that file and you reopen it, it will end up, it might come back up blank. When you click append, it will just open the file, add something, add more. So even if you reopen the file, it will keep adding to it. So most of the times we just use read and write because it's pretty simple. You don't need to go through the append and the read write. If you have to, okay. If you see it in a question, okay, right? So when I say open input.txt, I'm now going to have to put a while loop. Why I put in this while loop is because this while loop is going to say, while I am not at the file end of file. So while I am not at the end of the file that is named in, what is the file that's named in? Up here. What do I want to do? I want to scan scan f is the word you have to use, from the input file, an integer, and put it in the variable a. And then I want to print back out that integer that is in the variable a. What is in my input file? When I open up input file, I have random numbers. Right? So what's going to happen is this for loop is going to start, and the for loop is going to do scan. Alright, cool. Am I at the end of the file? No. I get 12, print back out the 12. Am I at the end of the file? No. I get 14, print back out the 13. Am I at the end of the file? No. Get print. Am I at the end of the file? No. Am I at the end of a file? No. Am I at the end of a file? And I'll keep going. Am I at the end? When it reaches here, it'll be like print 89, and then it will now say okay, yeah. Right. That's not again an error message from YouTube here. Is your problem? Okay, if all you're experiencing buffering or whatnot, just let me know. Right, so it'll be like, I'm at the end of the file, and once it reaches here, it says, oh, I am at the end of the file, therefore I am going to stop now, and then that's when the while loop will stop. Once that happens, you will see something like this happen. So my same text file that I have here with those numbers, you'll see them there: 12, 14, 16, 9, 8, 2, 8, 56, 78, 435, 23, 67, 89, 89. Those are the numbers that were read from the file, and those were the ones that printed back. If you okay with that, let me know what else it will help it. So you can read stuff from a file and put it straight in the structures if you want to. Just like how you do scanf here, you could scan it straight into one of the structures. Just waiting for comments. Okay, so yeah. All right, functions in a nutshell would be function like what's called an independent section of a program. So function is like an next planet. You just go to the next planet, do what you have to do, and then come back. Or think of your room. It's usually like the main, and you would go to the kitchen, get something done, and then come back to the main. You might go to the bathroom, get something done, come back to the main. You might go outside, get something done, come back to the main. There's always a main place that you come back to. So there are two types of functions: void and variable return. Now, I'm just doing this based on like straightforward teaching, but usually, as I said at the start, I need questions to know what people don't understand, but I'm just trying to explain it as thoroughly as possible and still make it simple for you. Alright, so you have two types of functions, void functions. So a void return does not send anything back. Normally, when you send something to a function, you would be like, your name is main. You would send something to a function. The function will do whatever it have to do, and then it'll send something back. But if it's a void function, nothing comes back. Void is just take it and do whatever it has to do, and you assume that it does its job properly. So if I have a function called void display, and its job is to print the sum of the function, print something, that is his job. He just prints that. There's never going to be a return. You don't have to send anything to it because it doesn't receive any inputs. Or it might receive inputs and still not give you back anything. But understand the concept is, it just does what it's supposed to do. Variable functions now, they receive values most of the time. Sometimes they do receive values, but depends. For the most part, you will do variable functions that receive values, and it sends it back. Now, it doesn't always work like this, but for explanation purposes, I needed to understand that this is how you would most likely have to do it. So, because it's returning something, you have to say what type of variable it's going to return. This is going to return an integer. What are the two things it's going to get? It's going to get a A and a B. When it gets the A and the B, it has to figure out, okay, what to do with the A and the B. So the main is going to send a A and send a B, and then in the function, you're going to create something called result or res, right? The job of this function is to create a result, add the A and B, and return the result. Where this is going to return to, it's going to return back to the main, wherever the main come from, as an integer, because I said this function is going to return an integer. So the main will get it back like that. So let's look at a small functions example and see if that makes sense. The functions, basic function. Okay. This one have plenty comments because functions have a lot of explaining to do. So if I have a function, now always declare the function at the top because it will the compiler will have to look for the function first, or else it'll have to do something called prototyping, and prototyping kind of weird. If your teacher teach you how to prototype, then okay, no problem. If not, it's alright. You can do it this way. So make sure the function is on top. So I have the name of the function is in sum, receiving A and B. I create a variable inside the function. Remember this this exists inside the function. My job here is to say A plus B and return result. Then I have the display function that's here, and its job is to just print out something, right? Now look at the main. The main says create an integer called y, and then create an integer called z. What do I want to store in z? I want to store in z the result of the sum function that's going to send 5 and y. What is y? Y is 2. So these are the two things that are going to be sent. So from this side, the number will be 5 and the whatever variable inside y will be sent. But what actually going to happen is it's going to switch, and it's going to be known as A and B inside here. So 5 will be represented by A in the function, and whatever is inside y will be represented as B, which is the number 2. Right? Then this function has full control. The function is going to do what it has to, whatever it has to do, and then return a value. So it's going to do the calculation, int res, create that, res is equal to A plus B, and then return res. What is going to happen is that res is now going to return to the main and be stored inside z. So this whole thing here is going to go to the function, give you back an answer, and whatever this returns, or whatever this works out to be, is going to be stored in z, and then I could just print back out y and z. So really what's supposed to happen, I'm supposed to get the sum of 5 and 2. So I'll show you here, you could send a variable to a function, or you could send a number to a function. Both of them will work the same way. So if I compile this, I will see that the sum of 5 and 2 is 7, because I sent 5 and then I sent y and it came back as 7. How did it come back as 7? Because the function itself got the A, got the B, which would have been 5 and y, added them up and returned it. When it returned, it was stored inside z, and then I printed it back out. And that's functions really quick. That's basic functions really quick. Advanced functions is kind of how to do that in our class. Safe. Well, that is all it is, you know. Let me know if you grasp it. Probably next week I might have to do some IT stuff. I might have to do data flow diagrams and data flow diagrams and maybe ERD diagrams, because those usually give students trouble. But if you have other code questions, send it on Instagram and I'll try to integrate them. So when I do the live, every Sunday night you'll you'll get an hour for CSEC and then an hour for CAPE, depending if it's computer science or IT. So, if you just watch this and you're glad that it made sense and I just changed your life or some kind of thing like that, that's good to know. The drill is as follows. I have computer science is on computer science lower 6 is Thursday. Computer science upper 6 is on Tuesday. IT lower 6 is on Thursday also, and IT upper 6 is on Wednesday. All classes are online via Skype. Right now, we're finishing out the modules, so from February is all past papers. I spelled all wrong. Wow. All past papers. Alright, so we're doing all the past papers from 09 up to 2018. Between February to May. Well, April, the end of April. Basically the day before your exam, and we're doing multiple choice and things too. So that's how it goes. Alright, thank you, and I hope it helped you.